Okay, so there's some big lineup this morning, isn't it, with us, Alison and an international speaker, and then Mr. David Densley. So, look, Connor was talking about biologicals, and if for those of you who knew about that, have listened to the Seven Wonders of the World that Fred Below discussed with us, biologicals was on there. I know that David is going to talk about on-farm work, long-term farm work that we've got going, and in that project, he's talking about tillage and the impact of tillage, and also I guess there's a bit around fertility as well. So they are also on the Seven Wonders of the World that Fred described. So look, David doesn't need any introduction, but I guess I'm going to take this opportunity, having been his manager for 3.5 years. You know, we set out 3.5 years ago to establish I guess an on-farm network alongside our NCS program. And look, I hope that it's been engaging for you guys. I appreciate, David, what you've done, and I'll leave the floor to you. Thank you, David.
That's awesome. Thanks, thanks, Andy, for that. And Connor, I know Connor's just ducked out there for a minute, but fantastic stuff. Dr. Below actually supported Connor coming over and talking to us, and we really appreciate that, because someone that's got that much experience can share that with us. It's fantastic. There was a bit of a competition going on with Fred Below and Connor and myself as to how many times Connor might say corn instead of maize. And so I don't know, he actually spoke corn one time at all. So fantastic. Whereas Fred actually lost that. He mentioned corn a couple of times in his presentation. So my last swan song, last time that I'm going to be in front of you wearing the FAR shirt, and Roland, thank you very much for your kind words this morning, and last night, Alison and the FAR team. That was just fantastic. I feel a little bit overwhelmed, and I just want to tone things down a bit and just say, well, okay, you know, what I want to just go through the journey of the last 3 years. I'm going to go over a bit of stuff you've heard before, and then I'm going to present some brand new information. So you've got to stay awake until the end, because there's some brand new stuff that only one or two of you have seen before. It sort of just pulls it together over the last 3 years. A couple of things. I just thought on my last presentation I need to set myself a big, hairy, audacious goal, and that's my title: Increasing Yield, Resilience and Profit through Improving Soil Quality and Agronomic Practices. So you've got to start out big. And I just want to acknowledge the team as well. So Sam and Steve, they do all the heavy lifting. So some of the numbers that I'm going to share with you today from their solid work, and I just want to recognise that. Okay, so let's just jump into this. And so this is what I'm going to talk about this morning. So Andy, you let me know when I've got about 5 minutes up, and then I'll run about 10 minutes over that. And so all good. Last presentation, so we'll get everything done. So I want to set the scene a little bit. Sort of going to refresh some of the stuff that we've talked about. Going to look at soil quality and its influence on yield. Going to dive into our on-farm research sites and some soil quality updates. Look at our maize establishment findings, and that's some brand new information that I'm going to share with you that will, I think, help shape where we go in the future. Preliminary review of the data, and then a summary, wrap it all up. So that's what I'm doing for the next 30 or 40 or 50 minutes. So let's get into that. Okay, so we're going to start with this. So I'm going to sort of build on this a little bit, and you know this, right? So this is Dr. Below's 7 corn wonders of the world that shot him to corn fame, maize fame all around the world. And, you know, so out of there, you know, we see these 7 key drivers that make up this 19 tonnes of maize grain yield that's set there. And so you can see that, and this is on the assumption that the prerequisites, those first principles, are in place. You've always got to have those first principles in place, and then once they're in place, this is what drives you know, the productivity of your production system. And I think this would, whether you're doing 19 tonnes or 29 tonnes, this is probably still the same order. So you think about those things. Out of those 7, there's only 6 that you can control, right? If we look at that, there's only 6 you can control. So you obviously can't control the weather, but we have talked about resilience for over the last couple of days. You can't control the weather, but your management practices can have an influence on how that weather impacts your productivity. So you do, in some ways, have some influence on the weather. So I want to look at this. And so I want to just look at the 2023 National Corn Growers Association Yield Contest. How many of you in this room know about this competition or the contest? Okay, guess who shot their hand up first? It was actually Connor down the back there. So well done, Connor. Okay, so a lot of you, or some of you at least, have heard about this competition or a contest. They don't call it a competition, they call it a contest. Some interesting stuff here we can learn from. Now, their maize production season runs in a calendar year, so the season that's just past them. We've got the couple of farmers that have won in certain categories. And so we see here the first place for the non-irrigated grain yield is 26.79 tonnes from Kevin Kolb. And so, you know, that's actually quite a spectacular yield. But now the world record has actually been broken again. So the new world record stands at 39.24 tonnes. So David Hula has actually broken his own record. So that's very, very impressive. Now, if you think this contest is just a couple of farmers coming together and it's no big deal, in fact, in 2022, the 2023 yield data has been released, but the detail behind that hasn't been released. In 2022, there were 6,337 entrants for the National Corn Growers Association contest. Each entrant has to have 4 hectares. So in total, there was 23,500 hectares of maize that farmers entered into this contest. Put that in context, New Zealand has about 75,000 hectares. So a third of New Zealand's maize production went into this contest. So it gives you an understanding of how many farmers are engaged in that. It's quite significant. This is another interesting bit of information out of the contest. So what we've got here is, on this axis, here's the yield in bushels per acre, just a quick maths. If you want to convert bushels per acre to kilos per hectare, you multiply by 62.9. You can do that in your head. Someone as smart as my boss, Andy Pittman, will do this straight off. Convert bushels per acre to kilos per hectare, just multiply by 62.9. It doesn't matter. So what we've got up here is we've got the years along this axis. So this data is from that yield contest that I talked about. So this is the average yield in America across all these years. And on average, this is grain, on average, the yield increases by 100 kilos per hectare per year. But you're already seeing this one up. Whoop, let me just go backwards. Yep. Push the right buttons here. Here we go. So what you're seeing here, though, is those that entering the contest, the non-irrigated group, are increasing their yield potential by 4.7 bushels per acre, or 295 kilos per hectare relative to these guys. So there's a couple of key messages in here. One, the significant yield potential that exists in that bag of seed that you buy and put out in your field, much, much better than cereal yield gains, and so we actually are in the right industry. And two, those guys that are in this girls that are in this contest that really focus on their productivity, their production systems, really drive the yield potential. Now, I'm not saying that necessarily there's profit in there. I'm just saying that the yield potential exists and a lot of the costs in your operation are fixed. So increasing your yield can and often does drive profitability. So then let's dig a bit deeper. So that's the potential out of that. So what do we need to do? And we talked about resilience. Now this is taken out of the Good Soils is Good Business booklet that FAR introduced. And it's the 6 principles of improving soil quality. So number 1 is avoid bare soils, or in other words, maximise living root days. And yesterday when we were in the field at the multi-hybrid, we showed you what we were doing with planting when we were planting our maize. So maximising the amount of living root days you have. The maximise below ground returns of organic matter, and I'm going to talk about that shortly. Minimise soil disturbance, integrate livestock and cropping. Now there's a little asterisk with that because if your soil types don't suit livestock over the winter, then you need to consider that. Increase plant biodiversity, and one of the challenges we've got in the maize industry is we don't have diversity. So when Fred was out here last year, we talked about soybeans. Is soybeans an option for us? What else can we rotate with? Interesting question. And the increase or retain soil fertility through biological means. So they're the 6 key principles around improving soil quality that we need to stay focused on. So this is an interesting study. So some of this stuff you might have seen before. I think it's useful to bring it back up again and revisit it, because this is an important bit of research. And this was some Southland work that was done on cereal production. So what we see here is, on this axis here, we see aggregate stability, which is an important driver for resilience in your soils. And along here we see the yield percentage. It's a percentage of the regional averages. And so you can look up here, and so if we had aggregate stability at 60% gave 100% yield. Anything above that gave a higher yield from improved aggregate stability. Now to put that in perspective, a reduction of 10% of soil structure, you lost an average 8% yield. So soil aggregate stability has an influence on yield potential, and if your practice is reducing your aggregate stability, you are less resilient. So here's another study that was in the Waikato, and this was done between 2002 and 2007. And this is looking at the aggregate stability along this axis here. We've got long-term pasture and we've got intensive agriculture. So what you see here is they're suggesting that the magic line here, well, not about the magic line, but you want to be greater than 1.5 millimetres in aggregate stability. And so here's the pasture range here that was done in the study. And here's where we're at in intensive arable production. So keep in mind the 1.5, because I'm going to share with you some data that we're looking at on the on-farm research. So I guess, what is your aggregate stability number on your farm? Do you know that? And I think we need to be looking at that in more detail. So talking about that, so I'm going to now talk about some of the research that we're doing on our on-farm sites. And this is looking at Colin Jackson's site. And what we've got here is, so this work was done just recently, and this site is now into its 3rd year. So we established the Maize system in 2021, in spring 2021. And we discovered there was a significant difference in aggregate stability between cultivation and no-till. And you can see it here. So what we've got is 2 different methodologies for determining aggregate stability, but they're both saying the same thing. So what we've got here is, we can see here the cultivation, and here we've got the no-till system, and there is a significant difference between the 2. And so remember that number that I suggested you keep in your head, 1.5. Anybody that's been on this site before, and Colin would be the first one to acknowledge that, is that this has had 50 years of long-term maize production under conventional systems, and these soils are actually degraded. And one of Colin's challenges is to reverse that degradation. And on our research farm, where we're looking at cover crops and no-till systems, we want to understand what these production systems are going to do to our soil quality, and then what it's going to do for our profitability moving forward. Over on this side here, we're looking at the different cover crops. And this becomes a bit interesting, because what we see here is the perennial ryegrass and the perennial clovers are influencing their aggregate stability compared to something like woolly pod vetch. And so what we see here is the underground root biomass is having an influence on aggregate stability. So there's absolutely something in there that we can pick up and learn from. So this is one of our other sites. This is at Alan Henderson's now. We moved this site, there's a background story I won't go into, but we moved this site from the first location to the second location. So we're only just starting out here. This is a different soil type. And so what we saw here is we're not seeing the same significant differences that we saw at Collins. That could be because it's a soil type, or it could be that we're only just on this journey. But we do see just the start of something going on here between our cultivation and our no-till, right? So we're starting to see, even after just 1 year, we start to see some differences appearing. And so Abby shared this information with you yesterday, but it fits in with the theme here. This is part of the long-term establishment at NCRS. And what you're seeing here is that we're just comparing the aggregate stability between the different systems. And again, Abby talked to you about that yesterday. And you see that no-till compared to strip-till and compared to cultivation has better soil aggregate stability. Remember that number that I shared earlier, and that Southland work showed that you do get a yield response from having improved aggregate stability. Now here's the fence line here, okay, so we're a long way short of the fence line, and I don't know whether in my lifetime, are you standing up to tell me it's 5 minutes? No way. Okay, let's go fast. Okay, and so the challenge is then, how do we get there, or how do we get close to that? Okay, so let's roll. I've got about 3 more slides. Brand new, in fact, I've got 3 more slides. This is the first time that most of you would have seen this data. So I just want to spend a couple of minutes on this. Okay, so what we've got here is, this is from 3 years of data, 165 assessments per establishment system. So what we've got here is this is looking at population. So we're at cultivation here, strip-till here, and no-till, right, in the box plots. And so really what you want is these tight box plots. You don't want to see a whole bunch spread. So what we've got here is our population, established population between cultivation and strip-till are more or less the same. But for our no-till, we have nearly 5% lower population under our no-till system compared to our strip-till and our cultivation. So first learnings, the first time we've pulled this information together, and that's what we're discovering. Second part, and this becomes really, really important here. So what we've got here is emergence uniformity. So on all our sites, we measure emergence uniformity. From when the first seedling comes out of the ground to the last seedling comes out of the ground in the row, you want them to be uniform. So we measure how uniform the emergence occurs, and so every day, once the first emergence occurs, we go in and measure that. So what we've got here is 2 days, day 1 plus day 2, of emergence. So what we see here is the cultivation and the strip-till. After day 2, we had about 85% of the plants all emerged. But look at our no-till system. It is behind these 2 systems, and on top of that we had significant amount of variability. So this is what this looks like. We were 17.6% behind with our emergence uniformity on day 2, compared to cultivation or strip till. Is that impacting our yield? You bet it is. And finally, our spacing uniformity, because there are a number of things we measure. And so what we see here is a little tighter gap, but we do see this slightly more spacing variability in the no-till versus the cultivation and the strip till. So if we're wanting particularly our no-till system to be competitive with these other systems, we need to figure out what's going on. Now, if you're going to ask me, can you explain what's going on here, David? The answer is, well, I actually don't have time, and no, that's the journey that we're on. We need to discover. Righto, so I've got 2 more slides, and then I've done Andy. So Andy's standing up. Okay, so a lot of data here. When I run this post, Andy said, "That's too busy, David. You don't want to put that up there. It's too busy." Okay, but I'm just going to talk just want to pick out a couple of numbers here. So this is looking at Colin's site here, and the reason I've used Colin as an example is because now we've got the most amount of data here. So what we've got here is the cultivation by the cover crops, cultivation by cover crops, strip till by cover crops, and no-till by cover crops. Okay. So what we're measuring here is establishment, emergence, maize silage yield, and gross margins here. And I just want to put this one in here. While we haven't done the stats on this, there's just something interesting going on here that we need to explore. Okay, so that's using our cover crops to be able to support our maize production system and to be able to drive profitability. Okay, so we're going to dig into this more, and when I say we, it's the royal we, of course, whoever I hand this on to, will start looking at that. So there's something going on there. And then finally, this is I just pulled up some data here, just out of, this is from the last season, and just looking at, here we've got gross margins, so we analyse all our data, and it's just looking at the relative gross margins by the different sites. And so we've got significance here at Allen's and at Grant's. Grant's, there's been a change of ownership at Grant, so we're no longer there. But you can see all that, and we've presented that data before. So that's where we're at. So summary, this is my last slide, Andy, we're done. Okay, number 1, fertility is the largest driver of yield potential after weather. Don't forget that. Non-irrigated entrants in the National Corn Growers Association contest had 2.95 times higher yield on an annualised basis compared to the average. Number 3, strong relationships between aggregate stability and crop yield. No-till and strip-till have better aggregate stability relative to cultivation. And compared with cultivation, no-till had lower established populations with more emergence variability and slightly higher plant spacing variability. And that's the end of my presentation. This is the last time you might see in my fast shirt. Thanks, Andy.
We are sort of running short, but David, just one question if anybody has a question. No?
You just want me to be quiet. That's
okay,
it, really.
so if you've got any burning questions, please speak to David afterwards,
Yep.
During the coffee break. So that's the end of the 3 talks in this session from presenters.